So when I build a classifier typically, right, so what is going to happen if I whether I am building this hyperplane business or whether I am using a discriminant function, right, there is an additional thing which I can use to tune how am I going to finally assign the labels, right. So let us say I have a 2 class problem, so then I can say that I learn a discriminant delta, and typically what we do, if delta is less than 0 we assign it to one class, delta is greater than 0 we assign it to another class, correct. Yes. So what if I tell you that no, if delta is less than some theta you assign it to one class, if it is greater than theta you assign it to another class, right. So what will this let us do? Let me move things around a little bit, right. So essentially what will happen is I can by changing this theta I can take some points which were originally classified as positive and make them negative, right. So one way or the other, right. So I just keep sliding theta around, right. So essentially right, so that is a line that marks where they are equal to 0, right. When I say that it is greater than some theta, so that essentially means I could either have a line this side, right, or I could have a line that side, right. And as I keep moving this, what happens when I move here, so this will become 0, that will become class O, right, this is already class O, now this will additionally become class O, right. Likewise when I move it that side, now this will become class X, right. So I can actually change where I pitch my line, right, and I can get different performance, right. So what is important here is, okay, I have figured out that, right, but then I can move this that way or that way a little bit and I can change my what is it?
What is the performance measure?
Whatever I want to do, right. So I can increase the precision of my classifier by just saying, okay, I have learnt the classifier, right, I have learnt whatever it is, I have learnt the hyperplane, but instead of looking at 0, right, I will just move it a little bit that side, right. When looking at the point where the probability is 0, I will move it a little bit that side or that this side, so that I can change my classification that I give, right. So given that I can do something like this, right, so how do I know I have got a good classification, right. How to put it? I put it another way, right. So I am asking you to give me a classifier, right, but I am not going to tell you, right, what is the precision I need or what is the recall I need from this classifier, right. So you give me a classifier and then I am going to figure out what is the theta I need to set, so that I get a good precision or a good recall or a good classification error, whatever it is, right. So I want to be able to tune this and figure out where I am going to settle down, right. So one way of summarizing all of this is something called the ROC curve, right. Right. So the x axis is the true positive rate and the y axis is the false positive rate. So what I mean by this, so at any point I am going to look at how many true positives could I possibly get, right, that is my denominator, how many of them I have actually obtained, that is my numerator, right. Let us take a simple example. Suppose I have, let us say I have 10 data points, okay, I am going to make it very simple. Let us say I have 10 data points, right, and 4 are positive, 6 are negative, okay, 4 are positive, 6 are negative, right, and I have a classifier, okay. So of these 4 points it gives me 3 here, and 1 here, right. Right. Yeah, so I got it right. Okay, fine. So it manages to tell me that 4 of the negative points are actually negative, right, and 3 of the positive points are actually positive, right, and 1 of the positive points it classifies as negative, and 2 of the negative points it classifies as positive, right. So of the true positive rate for this is essentially 3 by 4, right, and the false positive rate for this is false positive 2 by that. There are totally 6 things which I can say as false positives, right, of which only 2 I get as false positive, so I am not too bad, right. So that is the thing. So typically what you would want is, maybe I flip this thing around, right, is that TPR and this FPR? I am always get confused with this, huh? Right. So when I say something right, I need to go up, yeah. So that is TPR and this is FPR, right, yeah. So I ideally want a curve that goes like this, okay. So I should get 100% true positive rate before I start saying anything is false positive, right. Does it make sense? So here is 100% and here is 100%. So at this point I am classifying everything as positive. At this point I am classifying everything as positive, right. So I will have a 100% true positive rate because I got everything as positive, and I will have 100% false positive rate. So everything that I could say is falsely positive, I am saying it is falsely positive. So at this point I am classifying everything as positive, right. But then what I would really like to see is, when should my false positive rate start going up? After I have achieved 100% in the true positive axis, right. After I have classified every positive point as positive, then if I still ask you to move your classifier more that side, then I should start getting the negative points as positive, right. So you should really go up all the way here before you start moving this way, right. And what about that guy? This is essentially random behavior, right. I mean, so for every true positive guy I get an equal fraction of false guys as positive. So essentially I am just flipping coins and telling you whether it is positive or negative, right. So I am just flipping coins and telling you that this essentially gives me that line, right. Right. So the farther up you are, if the probability of you saying positive is higher, right. I am tossing a coin, like you give me a data set, give me a data point, I will toss a coin and I will tell you whether it is positive or negative, okay, right. If the probability of it coming up positive is low, then I will be somewhere here. If the probability of it coming up positive is high, then I will be somewhere here, right. Make sense, right. So that is this line, this is bad, right. You want to be above that line, you never want to be below that line, right. This is essentially random, right. You want to be above that line. So typical curves you find will be something like this, okay. So obviously you will not get that, right. Ideally you would like to get some curves like this, right. Make sense? Question so far? So the steeper this rise is, the better it is for you, right. So sometimes what happens, you get curves that rise very steeply and then do that. Is that a good or a bad ROC curve? Somebody said depends, yeah, of course. We all know the right answer is depends. Yeah. Huh?
Depends on how accurate
Yeah, depends on how, yeah, what type of performance I am looking at, right. So when will this be good, right. So when I want to achieve a middling true positive rate, right. So this is about middling, right, it is about 50% true positives. So that means of all the people with dengue I want to capture at least 50% of them, okay, without putting too many people on quarantine, right. So this is a good classifier. But then if I see, if you really want to get like 90%, right, then this becomes unacceptably high false positive rates. Well, this might not be that bad, right. You want to get 90%, so this might not be that bad a false positive rate, right. But then at this point this classifier is better. So if I want for 50% false positive rate, this classifier is better. For 90% false positive rate, this classifier is better. So there is no surefire way of saying this is better, that is better without knowing what you want from it, right. Just because I drew a curve that went below the random line really does not mean that this classifier is uniformly bad, right. So if you want to show true dominance, you have to show that one curve is above the other throughout, right. This white line truly dominates the pink line, that then now in such cases I can say white is better than pink, right, but not in these cases. In this case this curve is actually better for some points, some operating points, it is not better for some other operating points. So nobody asked me what ROC stood for. Huh? Yeah, receiver operating characteristics. Why do you think I wrote curve next to it? ROC curve, okay. Okay. So this essentially was used in olden days when people are talking about radars and things like that. So false detection, true detection versus false detection, right, and then you choose your operating point, right, based on how much how sensitive you wanted it to be. Do you want it to capture everything that came your way, in which case you chose a different operating point for your detector, right. So that is why these curves came about, and you can use it for the same purpose in your machine learning evaluation, right. You can use it to figure out which point in the space of parameters that you want your classifier to operate in, okay, make sense. Everyone get what ROC curves are all about, okay. So the thing with the ROC curves is, unfortunately, right, people do not really use it this way when they run experiments, right. So what do they end up doing? They do not want to look at the curve, right, they do not want to look at this curve and try to sit down and do an analysis and write papers, because they want to run hundreds of experiments, they want to generate 100 such curves, and they wanted an automatic way of comparing the curves. So what they did was they used this measure called area under the curve. They use this measure called area under the curve, or AUC, right. When they typically mean the area under the curve, they do not mention it, but they mean the ROC curve, right. So the area under the curve is essentially this, right. So the assumption is the larger the area under the curve, the better your classifier is, because the ideal classifier is the one that goes like that, right. So it gets all the positives before it gets the negatives. So the area under the curve is 1 for the ideal classifier, right, and the area under the curve is 0.5 for random, So, if you are somewhere between 1 and 0.5 you are better than random, so higher the value the better it is, okay. All of this is fine provided all your curves are of similar shapes, right, but you could get funky curves like this. So, what do you think went wrong here? So, the data is something like this, right. So, there are lots of zeros here and so on and so forth, and then there are a few more x's there and then a few more zeros there, right. So, if I want to get those x's correct, I have to get lot of these zeros as x's before I get those x's correct. So, that is essentially what is happening here. I am getting more and more of the zeros O's as x's here, and then suddenly I get those last two pieces, last two x's, and then I get there, right. So, that is essentially what this means. So, that your negative class, okay, is lying between two bunches of positive data points. So, you are getting all the initial set of positive data points, and then before you get the remaining positive data points you are getting a very large fraction of the negative data points, and then you are getting the positive data points, right. So, this could be an indication that your encoding, feature encoding is wrong, right, or you need to go to a different dimension. So, you need to do an expansion of the dimension so that you can get all the positives before you get the negative ones, but people unfortunately do not actually look at the ROC. In fact, there is all this codes basis for generating AUC directly, okay. You just run your experiments, feed the data, feed the classifier to your AUC generating package, and then out comes the string of numbers. Nobody even plots the ROC and looks at it anymore, right. So, you can actually get insights about what is happening by looking at ROC, okay. So, how would you actually go about plotting the ROC, okay. So, here is a very simple way of thinking about it, right. So, I am going to take all these data points, right, and arrange them in descending order of their likelihood of being positive. It could be any way I choose to do that, right. So, if I am going to slide this thing around, okay, the farther I am from the hyperplane, right. So, the less likely I will be, the farther I am on that side from the hyperplane the less likely I am going to be positive, right. So, I will start off from here and then I will slowly increase this, or if I am doing a neural network I can look at the probability of the classification, right. So, I can look at what is the probability this data point is going to be positive, right. So, like that. So, whatever is it I am going to arrange it in descending order. Let us say that oh, I do not need to do the predicted class. So, let us say that I am arranging it like this, right. Right. So, this is the true class, okay, this is the true classes, I have arranged it in this order, okay. Now, I choose a threshold above which I will classify this as positive, right. So, let us say I choose a threshold here, right. So, what do I get? No, 1/4, right. Right. So, I will just go up by 1/4 here, right. Next, what do? Next I move it down one more data point, right. Then what do we get? Half. I move up by another 1/4. If I see another plus, I move up by another 1/4. Likewise, next down, I will move up by another 1/4. Okay, assuming all of this is 1/4, right? Okay, so that means that will be 1. Okay. Now what do I see? I see a negative point. What do? I don't go down. I go right. I go right by 1/6. And I go right. Then another negative point. I go right. Another negative point. I go right. Right. And then go up. Then right. Right. Yeah. So my ROC curve is actually like that. Because I have only 10 points, it does not look like a curve anymore, right. This is all the estimates I can do, but this is my curve, right. Does that make sense? Right, and this is my random. in fact I should cross the random curve at some point, right, because I 3/4, what is that, 2/3, okay, that's fine, yeah, I'll still be above random, okay, that's fine, yeah. Right. So that's how I draw the ROC curve, right, fairly simple, right. So you arrange it in descending order of it being positive, right. So whenever you see a positive data point, as you go down that list, you keep going up. Whenever you see a negative data point, you keep going right. The step you go up is 1 by the number of positive data points. The step you go right is 1 by the number of negative data points. Right. Once you do this, now you can compute the area under this curve fairly easily.
Can you please repeat what was the criteria according to which we sorted?
So the probability with which my classifier thinks this point is positive, right, or whatever measure, right, whatever measure I am using. So it could be the distance from a hyperplane, whatever is the measure, the closer it is to the hyperplane, the less likely it is to be positive, right. I mean the farther it is from a hyperplane, the more likely it is positive. So whatever is the thing, I arrange it according to the criteria that I am using, right. Or if I am using a discriminant function, the larger the value for the positive things, then the higher up the ranking it will be, right. So like that, and I just do this in descending order of what is the probability I think it will be positive, or what is the likelihood I think it will be positive, right. So this is ROC curve. Any questions on ROC?
You are shifting the hyperplane as such, so
Yeah, that's why I said you start off from the leftmost end and then you keep ranking them according to whatever, you start off from the one end of it and then you keep ranking them according to that. But there are other ways of actually, once you train a classifier, when you do the hyperplane thingy, there are other ways of figuring out what the probability should be, right. So and from that you can okay, you do not have to actually shift the hyperplane around. So you figure out what the probability of the classification will be and then arrange them in the descending order of that, because you can always say that, okay, get my SVM to run, give me the output, give me the distance from the hyperplane for all the data points, I will convert that to a probability, okay, and then I will use the probability for making the prediction. If it is at least 0.3 probable that it should be positive, I will classify it as a positive class, right. And in decision trees again it is easy to do probabilities. So how will you do probabilities in decision trees? Look at the leaf the data point lies in and look at the fraction of data points belonging to one class, right, then you can do probabilities in decision trees. So likewise SVM is the only thing that is tricky, but you can, there is a way of converting the distance from hyperplanes into probabilities. Anything else I want to say here? Okay. So I am not sure if I am going to get to this later, so let me actually make the note now. There is another supervised learning problem, right. We talked about regression, we talked about classification. There is another problem called ranking problem, learning to rank, right. So it is inspired by information retrieval, right, but it is used in a variety of other settings, right. So I am not interested only in knowing if it is positive or negative, okay, that is not the problem, right. I want to know a ranking, okay. So where is this appropriate? So suppose I am yeah, so this is something which people do when they are trying to match protein structures. So I will have one structure for a protein, right, so and I want to figure out all proteins that look similar to this, right, which will probably have the same functions that as the original protein that I am looking at. So there I am not interested in you telling me whether it is similar or not similar, I actually want you to rank it, right. Or there is another question, so I want you to build a recommender system for me, right, I want you to predict whether I like a movie or not like a movie, right, but I do not want you to end up giving me like or not like, okay, I want you to give me a ranked list of movies, okay. So okay, this guy is coming in, okay, these are all his history, last movies that he has seen, okay, and he is an old guy, so these are the set of movies I am going to recommend to him, right, but in an order. So this is what learning to rank means. I am not just interested in yes or no answers, but within the yes I am interested in ranking order, right. It turns out that one of the ways of improving the performance in the ranking, right, is not to look at just precision and recall and specificity and sensitivity and things like that, it is trying to directly optimize the AUC. trying to directly optimize AUC, trying to improve the things. Essentially what it means is the more relevant items you are trying to push up in the ranking, right. So improving the AUC means what, you are essentially making the curve go steeper and steeper, right. Improving the AUC means you have to make this curve rise steeper and steeper, that is why, that's when we will get a higher area under the curve, right. So that essentially would correspond to making more and more of the positive points come higher up the ordering, right, because this is a rank order, right. So you are trying to push things higher up the ordering, so that essentially gives you the ranking effect.